Systems of linear equations in two variables. A system of linear equations in two variables is simply two equations in two variables that are linear. So here's an example. 3x minus 2y equals 6 is a linear equation because both x and y are raised to the first power. And 2x plus 4y equals 20 is also a linear equation for the same reason. Now, each of these linear equations have infinitely many solutions. So, for example, if you just concern yourself with the first linear equation here, let me just give you a couple of solutions. If x is equal to 2 and y is equal to 0, if you plug those in, you get 3 times 2 minus 2 times 0 is equal to 6. And this is, in fact, a true statement, but it's not the only solution. For example, x could be equal to 0 and y could be equal to negative 3. This is another solution. And to see that, we have 3 times 0 minus 2 times negative 3 is equal to 6. And this would be 0 plus 6 equals 6, right? So that's a solution. And you can see that both of those solutions are on the graph. So x equals 2, y equals 0 is this point right here. And x equals 0, y equals negative 3 is this point here. And in fact, we can use those 2 points to graph the line. Now, if we do the same thing for the second equation, you can find, again, infinitely many solutions to that equation. And if you graph those solutions, this equation here ends up having the graph that you see here. So what does it mean to find a solution to a system of linear equations? Well, it means that we are trying to find the one point, assuming that there's only one, the one point where both of these lines intersect. And in this case, that one point is the point 4, 3. So if you take x equals 4 and y equals 3 and you plug it into both of these equations, you can verify that it makes both equations true. And it is the only point that satisfies both equations. So basically, when you're solving a system of linear equations in two variables, you are trying to find the point where two lines intersect. But here's the thing. We don't want to find the solution by graphing. We want to have an algebraic method for doing this. Before we talk about the algebraic methods, let's consider three possibilities for solutions to systems of linear equations in two variables. The first case is that there is a single solution. So if you have two lines and they intersect in a single point, there is one solution. But it is possible that the lines are parallel. And if the lines are parallel, they do not intersect, in which case there would be no solution. And the third case is it could be that the two equations for the line actually end up giving you the exact same line. And in this case, there is an infinite number of solutions, right? Because basically one line is right on top of the other line, and all points on the line would be a solution. Now, the truth is, the vast majority of the time, you're going to have one solution, but we will discuss the other two as well. The first method is called the addition method, and this is a method that uses addition. We are simply going to add the two equations together to see if we can cancel out one of the variables. Now, if you notice right here, if you add these equations, 4x plus 2x is going to be 6x, 3y plus y is 4y, and 10 plus 4 is 14. Nothing canceled out. So before we can add these, we need the coefficient of the same variable to be opposites of each other in each equation. So for example, what I can do here is I could take this first equation and I can multiply it by negative 2. Now, if I do that, I have to multiply by negative 2 on both sides. And why would I multiply by negative 2? Well, let's do it, and you'll see why we did it. So negative 2 times 2x is negative 4x. And then we have negative 2 times positive y, which is negative 2y, and then equals negative 8. And then if we bring in the first equation, which was 4x plus 3y is equal to 10, I hope you can see now that if we add these two equations together, negative 4x and positive 4x are going to cancel out. So the reason I multiplied by -2 here was to make the coefficient of x the opposite of the coefficient here. So now let's go ahead and add. So if we add, these cancel out. And then -2y plus 3y is actually just y, and -8 plus 10 is 2. So we now know that y equals 2 is the y coordinate of the point of intersection of these two lines. Now, once I have y equals 2, we need to know what does x equal. So simply take y equals 2 and plug it back into either one of the equations. I'll just plug it into the first equation. So when I plug in y equals 2, we end up getting this, and we have 4x plus 6 equals 10, subtracting 6 from both sides. And then finally, dividing by 4 on both sides gives us x is equal to 1. And so now we know the solution is x equals 1 and y equals 2. And then, of course, as a point, this would be the point 1, 2. So if you were to graph these two lines, they would intersect at the point x equals 1, y equals 2. So a quick summary of the addition method, and you can pause here if you would like to read this. But basically, you're going to decide which variable to eliminate, multiply one of the equations or both of the equations to get the coefficients to be opposites for one of the variables. Then you add the equations together, and then you solve for the remaining variable. And then once you solve for one of your variables, you plug it back in to solve for the other one. So here is another example. We have two equations, 3x minus 5y equals -2, and 2x minus 3y is equal to 1. And we're going to solve this by using the addition method. So first thing I need to do is decide which variable to eliminate. I could eliminate the x, or I could eliminate the y. And it really doesn't matter most of the time, but sometimes one might be a little bit easier to eliminate than the other. In this case, I think it's pretty much the same either way. So what I'm going to do is eliminate the y. And I'm doing the y because we eliminated x in the last problem. So let's go ahead and eliminate the y. Now, to eliminate the y, notice that you have -5y and -3y. So I need to find the least common multiple of 5 and 3, which of course we know is 15. And we need one of these to be turned into a 15y, and we need the other one to be turned into a -15y, right? Because we want those to cancel out when we add them. So if I want my -5y to be turned into a positive 15y, to do that, I'm going to need to multiply both sides of this equation by -3, okay? Now, when I do that, this becomes -9x plus 15y is equal to +6. And then in the second equation, I need this -3y to be turned into a -15y. To accomplish that, I only need to multiply by +5, right? Because it's already negative, so I just need to multiply by +5. So if I do this here, we're going to get 10x minus 15y is equal to 5. And now if we add these together, we get 1x, right? -9x plus 10x is 1x. The positive 15y and -15y cancel out, and we end up getting equals 11. And so we now know that x equals 11, and now to solve for y, I can plug that back into either one of these equations. I'm just going to plug it into the second equation, I guess. So that's going to give us 2 times x, which is 11, minus 3 times y is equal to 1. This is 22 minus 3y is equal to 1. If I subtract 22 from both sides, we get -3y is equal to -21. And if I divide by -3 on both sides, we end up getting y is equal to 7. And so the solution here is x equals 11 and y equals 7, or as a point, we can simply write that as 11, 7. So here is another example. We want to solve the system, again, by using elimination. Now in this case here, we have negative 3y and positive 5y. So if I chose to eliminate the y's, I could once again turn these into 15y. And this time, I already have a negative and a positive. So all I would have to do is multiply this one by 5 and this one by 3, and it would be a very similar procedure. But if I chose to eliminate the x's, notice that the least common multiple of 2 and 4 is 4. So if I choose to eliminate the x's, I only need to adjust the first equation. 2x minus 3y is equal to 4. To eliminate the 4x here, I need this 2x to become a negative 4x. So to accomplish that, I'm going to multiply both sides of this equation by negative 2, because negative 2 times 2x will give us the negative 4x that we need. So this equation becomes negative 4x plus 6y equals negative 8. The second equation is 4x plus 5y is equal to 3. And now if we just add these together, the x's cancel out, and we end up getting 11y is equal to negative 5. And then dividing by 11 on both sides, we end up getting y equals negative 5 over 11. Now, that's not a very nice answer, but it's still the answer. And to solve for x, we can do one of two things. Of course, you could just plug in the number negative 5 over 11 into here, let's say. So if I do that, we get 4x plus 5 times negative 5 over 11 is equal to 3. And this is 4x minus 25 over 11 equals 3. So I'm just basically recognizing that this is 5 over 1, and I'm multiplying these together. And then to solve here, there's a couple of different things I could do. So I could just add 25 over 11 to both sides. Or if I want to get rid of the fractions, I could multiply by 11 on both sides. And this would end up giving us 44x minus 25 is equal to 33. And then adding 25 to both sides, we end up with 44x is equal to 58. And then dividing both sides by 44, we get x is equal to 58 divided by 44, which is the same as 29 over 22 when you reduce the fraction. So this, of course, would give us a final answer of 29 over 22, negative 5 over 11. And this would be the point of intersection if you graphed these two lines. Now, of course, this is why graphing is not a good method, because when you have fractions as your points of intersection, it's very difficult to see exactly what those values are when you're graphing. Now, I did mention that there is another way to find x so that you can avoid having to plug in a fraction and go through all this, even though I don't feel like this is really that bad. But what you can do is you could take your original system that we had in the beginning, so this system up here, and I could have just eliminated the y's, right? So we can take the system, and to eliminate the y's, I would just multiply the first equation by 5 and multiply the second equation by 3. This is going to give us 10x minus 15y equals 20, and 12x plus 15y is equal to 9. And then if we add these equations together, we get 22x, these cancel, equals 29. And then dividing by 22, you can see we get x equals 29 over 22. So that's another way to find the x-coordinate like we found over here. Okay, so it's really up to you how you want to do it. Let's go ahead and do one more solving by the addition method. So again, if I want to solve this, I can recognize that to get rid of the x's here, all I would have to do is multiply this first equation by positive 2 on both sides. And that's because 2 times 5x is 10x, and then 2 times negative 2y is negative 4y, and 5 times 2 is 10. And then you can see the second equation here. And when I add these together, the x's cancel out, but also notice that the y's cancel out as well. And so we're left with 0 on the left-hand side and 25 on the right-hand side. And of course, we know that 0 is not equal to 25. So what does this mean? Well, since 0 is not equal to 25, it means that this system has no solution, okay? Now, the reason for this is because if you graph these lines, they end up being parallel. And here is that graph. So you can see that these two lines clearly do not intersect each other. And that is why there is no solution to the system. Okay, actually, let's do one more using the addition method. Same thing here. If I want to solve this, I need to eliminate, say, the x variable, and I can do that by multiplying both sides of this equation by -2, because -2 times 4x is -8x, -2 times 3y is -6y, and then equals 2 times -2 is -4. And then the second equation is here, and just like before, when you add these together, the x's cancel out. The y's also cancel out, so again, you have 0 on the left side, but you also have 0 on the right side. And this is a true statement. So the solution here is a little bit different. It's not no solution. In fact, if you graph these lines, you will see that they are the same line. And so this is what both of those lines look like. So then what is the solution? Well, the solution is the lines intersect at every point that is on that line. So there are infinitely many solutions. So the solution is the set of all points, x and y, such that x and y have to be on that line, which means they have to satisfy one of these two equations. And it doesn't matter which one we write down, because in essence, what's happening here is these two equations are the same. They're the same equation. That's why when you graphed it, you got the same graph, okay? So the solution is basically just all points on the line, and that's what this means. All points such that they are on this line. Now, what if you're given a system that has a bunch of fractions in it like this one? Basically, what you want to do here is clear the fractions. So the least common denominator of this first equation is 6. So if I just multiply both sides by 6, we're going to get 3x minus 2y is equal to 12. And then for the second equation, notice that the least common denominator there is 12. So if I multiply both sides by 12, we're going to get 3x plus 8y is equal to 72. Now, once the fractions are taken out of the problem, it's just like what you've done before. So what I would do in this case is I would simply multiply both sides by -1, because that's going to give us -3x plus 2y equals -12. And the second equation is 3x plus 8y is equal to 72. And now when we add these equations together, we get 10y is equal to 60, which means y is equal to 6. And if y is equal to 6, we can plug that in, say, to here, which will give us 3x plus 8 times 6 is equal to 72, or 3x plus 48 equals 72. Subtracting 48 from both sides, we get 3x is equal to 24, and dividing by 3, we get x equals 8. So the solution here is x equals 8, y equals 6. Now, there is a second method for solving systems of linear equations, and it is called the substitution method. And the substitution method basically just means you're going to substitute one expression into one of the equations. So here we have the system 2x minus 3y is equal to -6, and y equals 3x minus 5. Notice that in the second equation, it is already solved for y. So because y is equal to 3x minus 5, I can replace y in the other equation with that expression. So this first equation becomes 2x minus 3 times y, which is being replaced with 3x minus 5, and then equals -6. And see, when you replace the y here, you're getting rid of the y and you're bringing in an x. So now we can just solve this for x. So we have 2x minus 9x plus 15 is equal to negative 6. Combining like terms, we have negative 7x plus 15 is equal to negative 6. Subtracting 15 from both sides, we end up getting negative 7x is equal to negative 21. And finally, dividing by negative 7, we get x equals 3. And then if x equals 3, y is going to be 3 times 3 minus 5. So I'm just taking this answer and plugging it into here. And that is going to give us y equals 9 minus 5, which is 4. So the solution is x equals 3, y equals 4, or once again, as a point, we can write that as 3, 4. So which method is better? Well, I like to say that you can use whichever method you prefer. I do think there are times when one method might be a little simpler. In this case, I feel like the substitution method is simpler because your y variable was already solved for, which allowed us to plug it in very easily. But the truth is, it doesn't really matter which method you use. It's up to you. So a brief summary of how to solve a system of linear equations by using the substitution method. First, solve one of the equations for one of the variables. And in the last example, this was already done for you. Substitute that expression for that variable into the other equation, then solve that equation for the remaining variable, and then find the second variable and check your results. So here, let's solve by substitution. So notice that we do not have x or y isolated yet, but in the second equation here, we can solve for x very easily by simply adding 2y to both sides. And that would give us x is equal to 6 plus 2y, or 2y plus 6. And then once I have that, I can take 2y plus 6 and plug it into the first equation, replacing x, right? Because x is now equal to that. So this becomes 2 times 2y plus 6 plus 3y is equal to 5. This is 4y plus 12 plus 3y is equal to 5. Combining 4y and 3y, we get 7y. Subtracting 12 from both sides, we get negative 7. And so y ends up being negative 1. And then we take y and we plug it into here, and that gives us x equals 2 times negative 1 plus 6, which is negative 2 plus 6, which is equal to 4. And so the solution is x equals 4, y equals negative 1. And that concludes this video lesson.